Welcome to this video on Kubernetes Metrics Server. In this tutorial, we'll explore how the metrics server collects resource metrics and enables horizontal pod autoscaling functionality in Kubernetes. Understanding the metrics server is essential for anyone working with autoscaling in Kubernetes clusters. The metrics server is a cluster-wide aggregator of resource usage data. It collects CPU and memory metrics from kubelets running on each node in your cluster. Think of it as a centralized hub that gathers information about how much computing power and memory your applications are using across the entire cluster. The metrics server has several important characteristics. First, it's a lightweight and scalable component that doesn't consume many resources itself. Second, it does not store historical metrics data, meaning it only keeps the most recent measurements. Third, it provides real-time metrics through APIs that other components can access. Finally, it's essential for HPA, which stands for Horizontal Pod Autoscaler, and VPA, which stands for Vertical Pod Autoscaler, to function properly. Let's understand the workflow. The kubelet on each node collects metrics from the pods running on that node. This data is then sent to the metrics server, which aggregates and exposes it through an API. Finally, auto-scaling components like HPA and VPA consume these metrics to make scaling decisions. This creates a continuous flow of information that enables dynamic resource management. Installing the metrics server is straightforward. You can use kubectl apply with the -f flag followed by the GitHub URL for the latest metrics server components YAML file. This single command downloads and deploys all the necessary components to your cluster, including the deployment, service account, and required permissions. After installation, you should verify that the metrics server is running correctly. First, check if the metrics server deployment exists in the kubesystem namespace using kubectl get deployment. Then, verify the pod status by listing all pods in kubesystem and filtering for metrics server. If the pod shows a running status with 1 out of 1 containers ready, your installation is successful. Once installed, you can access the metrics using kubectl commands. Use kubectl top nodes to view resource usage for all nodes in your cluster. Use kubectl top pods to see CPU and memory consumption for pods in the default namespace. For pods in a specific namespace, add the -n flag followed by the namespace name. These commands provide instant visibility into your cluster's resource utilization. Now let's understand how the metrics server connects with Horizontal Pod Autoscaler. HPA queries the metrics server to get current resource usage information. It then compares these current metrics against the target thresholds you've configured. Based on this comparison, HPA automatically scales the number of replicas up or down. This entire process enables dynamic workload scaling in real time, ensuring your applications have the resources they need while optimizing cluster efficiency.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.